All right, let's continue on with section 9.3. I've switched to my computer here because I'm going to be using some Desmos graphs, and so you probably want to have a Desmos screen ready nearby so you can also do the same thing with me. When we're looking at some of these graphs of cosine and sine, it asks us, when we're looking at them, at what values of theta, whoa, gotta push the button, at what values of theta do our, sorry, trying to pick at that thing. That's so strange. Okay, I got it now. At what values of theta do these things have the same measure, right? Does cosine equal sine? Okay, a couple different ways that we could look at this. One super fast, easy way is to use our nifty unit circle chart. We're looking at places where the coordinates are the same, where they equal each other. Now I'm zooming in here on this point right here, but those are actually not equal to each other because one of them is negative and one of them is positive. So they're both square root 2 over 2, but when one is positive and one is negative, they're not going to equal each other. All right, so we're looking for places specifically where they are both positive or where they are both negative. And I see one of them's happening right here at pi over 4, square root 2 over 2. So we see a couple places where if we were to graph these on top of each other, great thing to sketch in your workbook right here. We know we've got one that starts at 0 and goes up, comes down, back to where it started. One that starts up at 1, crosses down, hits that low point right in the middle, comes back up, and then meets here. So there are two places where we should be seeing intersections between these two. One here in quadrant 1 and one here in quadrant 3. So the place that we're looking where square root 2 over 2 equals square root 2 over 2, this one happens at pi over 4, right up here in quadrant 1. And then we said our other one's happening down here in quadrant 3, where negative root 2 over 2 equals negative root 2 over 2. And that is happening at 5 pi over 4. So pretty cool things to see where these things are happening, right? We had 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and that's where this one hits the lowest and where this one hits right here. There's 4 pi over 4, or just pi. 5 pi over 4 is where they're both hidden equal to each other. Okay. I can go to a Desmos graph, and I can also see the same thing there, so I'm going to do that with you here. On your Desmos graph, just go to the little wrench in the side. It's going to open up some of the menu items that we have. I'm going to do that first. Just double check that you are in radians here. Okay, radians, different than degrees. We don't want degrees, we want radians, right? And so if we just have the sine of x and cosine of x, we can see that these two are equal to each other right here, and it even marks it for us so nicely on our Desmos screen, which is pretty awesome, right? That it's marking where both of them cross at pi over 4, and here where they also both cross at 5 pi over 4. So pretty powerful to see these two things on top of each other. Now if you're like me, you're already kind of thinking ahead like, whoa, we could start adding all kinds of stuff, because this looks kind of cool, right? Kind of reminds me of the spirograph that I used to play with when I was a kid. We can start actually using our skills from Unit 5. Spoiler alert, this is coming later in the unit. And we can start shifting these graphs left and right. Right? So if I end up shifting a graph like to the left, and if I want to do pi, I don't know if I can just type, I just typed in the word pi and it did that. Now I've got another graph going on. Kind of cool, right? I shifted it a whole pi, and then I can add some more other stuff like sine of, let's do x minus pi. Same graph. Right on top of the green one. What if I did it 0.5 pi? And now we're doing like Celtic stuff. Sorry, way advanced. I'm kind of geeking out over here. So these are the two that we're supposed to be graphing. Come back to reality. But there's a little bit more here, and also a great reason why we're still using technology. For each of these equations, predict what the graph looks like, and then check your prediction using technology. Well, I'm going to skip down to part D, because that's looking pretty familiar. Cosine squared plus sine squared. No matter what's going on there, cosine squared plus sine squared, this is that Pythagorean identity. And so cosine squared plus sine squared should always equal 1. So when we add these two together, I predict that our graph is going to look a little something like this. Just a horizontal line at 1. Now as far as these other ones, something squaring it, this is kind of tough to predict. We can start taking some of our key points around the unit circle that we've talked about, and we can also make some predictions about what they're going to look like. Here's pi, here's 2 pi. So I'm looking here now at the cosine squared one. Well, our cosine starts off at 1, right? So when the theta is 0, it's at 1. But now I'm squaring it, and 1 times 1 is still 1. And then cosine, following this graph up here, by the time it gets to pi over 2, it's 0. And 0 times 0 is 0. But here's where the interesting thing starts to come in. By the time I get here at pi, cosine at pi is -1. And -1 squared, -1 times -1, is a +1. So, I might have a tiny little graph going on that's going to kind of match that cosine graph. Might have a little double going on here. Let's go double check. All right, we're going to give this a try in Desmos. So take that cosine graph. I'm just going to turn off my sine graph. And we want to do cosine squared. And now that's matching what I expected. 0, 1, pi over 2, 0, pi 1, 3 pi over 2, 0. And now at 2 pi, I've now done 2 full periods here, so it's like gotten twice as bumpy. Notice it's not going negative either, because any negative number that we had, we're squaring it. And so what we're going to have is this kind of bumpity. Okay, something that kind of looks like a really curvy W, but it always stays positive. Kind of neat. We could do the same prediction for sine squared. So I'm going to take this one and draw it over here so I've got a little more space. Always thinking about how things relate to pi and 2 pi and some of the other tick marks in between. Now sine is our one that started at 0. And 0 times 0 is still 0. It ends at 0. 0 times 0 is still 0. And it crosses 0 at pi. 0 times 0 is 0. And then we've got the same kind of idea going on as we had for our cosine graph. I'm going to go over to my Desmos and just show you what that looks like. Adding a squared to my sine, turning that graph on, and my cosine graph off. I don't know if I can. And now I see, starts at 0, by pi over 2 it's up at 1, by pi it's at 0, 3 pi over 2 it's at 1, and by pi it's back to 2 pi. So now I have kind of this curvy M going on instead of a curvy W. And it's still doing kind of that same thing here. So I'm going to draw that kind of curvy M, and it's going up to 1. It's never getting below the x-axis. And so by the time it's gone here, it's gone up and a down. Ooh, I need to look again. By the time it got to pi, yep, it just had an up and a down by the time it got to pi. And by 2 pi, it's gone another curvy part of the m and back down here. Pretty cool. Let's check a and d, cosine plus sine and cosine squared plus sine squared. All right. So I'm going to go back up here, adjust my equation so it doesn't have an exponent. I have sine plus cosine of x. Ooh, this is kind of interesting, doing some neat stuff. I want to check out some different points. Starts at 0, 1, goes above 1. This is the first time this has happened. By 3 pi over 4, so like halfway through quadrant 2, it's back at 0. 5 pi over 4, it's down at our minimum. 7 pi over 4, we're back at a 0. And by 2 pi, oh, I have to even figure out where 2 pi is. 6 point something. Boom, boom, should be right about there. We're back to where we started at 1. Hard to find that point exactly. There we go. So, let's draw this one in. This is a pretty unexpected graph. I'm going to change my colors so I can keep track of what I'm drawing where. This guy goes both above and below 0. Bounces from a height of 1.41 down to a negative 1.41. Starts at 0, 1, so that's a good place for us to begin as we're sketching our graph. Starts at 0, 1, goes up slightly, comes down to that negative, and goes down here. So, like, maybe you're saying a max is 1.414, and the min was down to negative 1.414. We can keep on going back and forth through our Desmo screen and just kind of seeing where we're going, but we want to do a full wave and kind of wind up back where we started by the time we get to pi, 2 pi. Okay, so by the time we get to 2 pi, I need to go down and I need to come back up, but not quite up to the top like that yet. It still needs to keep on going. One last one to check. Let's just throw some squareds on these and just double check part D. Adding squared to my sine, adding squared to my cosine, and that is the exact thing that we drew. No matter what we're putting in for our angle measure, we are getting 1 out when we add sine squared and cosine squared, just like we were expecting. All right, lesson 9 in the books.